today's video notes, we will look at inequality word problems. There are key inequality words and their meanings in word problems are as follows. At least will always mean greater than or equal to. That you can have at least $200 in your bank account, but you might want to have more. At most means less than or equal to. That at most you want 500 cupcakes for the party, but you can have less than that. No more than means less than or equal to is so again, you don't want to surpass that limit. You want everything underneath and equal to. No less than means greater than or equal to, that you want to, at a fundraiser, raise no less than a certain amount of money, but it would be good to make more. That's why it's greater than or equal to. More than means greater than. Our symbol for greater than is opening this way here. Make sure you know that symbol for greater than. And then less than is opening this way, this symbol here. How I remember less than specifically, and then I know the other part is greater than, is I make an L out of the sign and write it into a less than symbol. So if I can write less with a symbol, it's less than. Greater than, it wouldn't work. It'd be a backwards L there. So that's what helps me remember. Inequality word problems in one variable. When and how can we tell the word problem has only one variable? It's when we only have one value unknown. One variable, one value, one category unknown. Let's go ahead with example A. The yellow cab taxi charges $1.75 flat rate. So let's start there. In addition, when I see the word addition, I know that's definitely adding here. 65 cents per mile. The word per also tells me that that will be multiplication. Per is absolutely always multiplication there. Katie has no more than $10 to spend on the ride. That no more than is going to go on the right side of my inequality with 10, and it's going to be less than or equal to that 10 because she has $10 on herself to spend on this taxi ride. She can't go over because then she wouldn't be able to afford it. So she has to stay within the budget she has, maybe in her pocketbook, her wallet, her pocket. The 175 is a flat rate fee, so we know that that doesn't change. It's just going to stay the same. But in addition, it's going to put a plus sign between that and the 65 cents per mile here. So 65 cents each mile. So 1 mile would go 65 cents and 2 it would accumulate as well. So let's trade out the mile for X because that's usually the variable we like to use here. That's usually what we're solving for all the time. And that's exactly what we're going to solve for here. We move over the 1.75 on each side, and that gets us 0.65x is less than or equal to 8.25. We divide 0.65 on each side, and we get our final answer to be x is less than or equal to 12.7. What we do here is we answer the question at hand, which says, how many miles can Katie travel without exceeding her budget? Miles can be in decimal format, so we will say 12.7 miles without exceeding her budget. That's how far she can go. Don't need to write a full proper sentence, just need to answer the question at hand with a little bit of words or phrase. We're going to look at this example B and kind of go through it together, but we'll also have another example B as well, just for some extra practice. Sir Gerard needs no less than $159 to purchase a new guitar. So right away, no less than is going to set us up with greater than or equal to 159. It is important to note that Gerard can have $159 to purchase the guitar. He can't have under that. He can't have like 150 because it's 159 and he wouldn't be able to purchase it. But He can have money left over maybe for some other guitar cases or guitar picks or accessories or anything else he wants to buy. So he can have more than or equal to the 159, but anything below that he won't be able to purchase the guitar. He already has 38 in his savings account. So that is starting here with 38, and then we add on $5 a bag that he rakes. So 5 per bag. So again, each bag you'll earn $5 on. So that's why we have it changing with multiplication there. We go ahead and swap out the bag for X and move over 38. That gets us 159 minus 38, giving us 121, where we divide by 5 on each side to get X is greater than or equal to 24.2. It's important to answer the question at hand when we're given a word problem, which is what is the minimum number of full bags? So right away, I know that it has to be a whole number and it has to be greater than or equal to 24.2. So that's why I round all the way up to 25 full bags. 24, if I plugged it in for X, would not satisfy that inequality. 24 is not greater than 24.2. That's why you have to round up to the full bag of 25 to make this statement true. So always make sure to answer the problem at hand and know if you have to round up or down using the proper plugging in of the X to see which one's true. For this example B, we have Gerard now selling books online. He makes a flat profit of $20 per book. So right away per book, we know that is multiplication and it doesn't waver for $2 a book. From there, he has to pay a $4 fee to PayPal for using the app on his website every day. So since he owes that and he's not making money on that, he's losing money, we then subtract 4. Think about pays is not counting towards the money he's earning, he's losing that money he's having to pay. Then, how many books does he need to sell to make no less than 120 per day? So right away, it's going to be greater than or equal to 120 because he must make 120 per day, but he can go over that. That's his goal. That's how many books he's looking to sell each day. We go ahead and solve this inequality by adding 4 over to the other side to get 2x is greater than or equal to 124. Divide each side by 2, and we get our answer of x is greater than or equal to 62. So, how many books does he need to sell? To make no less than 120 per day, he must sell 62 or more. And we'll put 62 or more books sold. That's what he needs to make his daily goal of 120. That includes the $4 he loses each day to PayPal for having that on his website. Example C, Casey is planning a birthday party for her little brother and wants to rent a snow cone machine. She will also need to buy the flavored syrup, ice, and paper cones. She has at most $50 to spend. So that's the money she's willing to spend on the party, but no more. So 50 she can spend. 49 she could spend, maybe save some money, go to 40, but she can't spend and doesn't have the money to spend over 50. If she just has a $50 bill, can't go over that. Can be under that, that's why it's a less than or equal to. The rental of the snow cone costs $25 for the day. So that's just for the day. That's a set fee, so that will be added and included in her total cost. What changes is the flavored syrup, ice, and paper cones will cost 70 cents per serving. Per is a great word for multiplication because we have to account for each time it is served. So 70 cents per serving. We will now go ahead and solve the inequality we just set up, which is 25 plus 70 cents times that x. Let's swap out x for servings. and this will be less than or equal to 50. So I subtract 25 on each side. That gives me 70 as a decimal, so 0.70 is less than or equal to 25. Divide each side by the decimal of zero point 0.7 here, and we get our final answer to be x is less than or equal to 15.7. And now to answer the final question here, we want the greatest number of snow cones Casey can serve. Well, it has to be less than or equal to 15.7. So I have to go down to 15 snow cones served. Because if I go up to 16, 16 is not less than 50.7. That's an untrue statement. So that's why I have to go down to 15 to make it true. She will have a little bit left over, but not quite enough to make one more snow cone there. Has to make sure she has enough for a full snow cone. Don't want to serve half or 0.7 of a snow cone. From here, let's do example number D, which is 2/3 of a number. Of a number really is going to talk about multiplication there. So that will be 2/3 multiplied to x, which is a number. Or we can even put before we swap out x, multiplying that 2/3 by a number. Then we will have plus 5, which means addition of 5 there. And it's greater than, no equal to with it, just greater than 12. Then we'll go ahead and find the numbers. So we go ahead and have 2/3 times x plus 5 is greater than 12. Move over the 5 first before we deal with the fraction of 2/3 multiplied to x because it's now greater than 7. Since it's 2 divided by 3, I can break this up by multiplying that 3 on each side because the opposite of dividing by 3 is multiplying by 3. That will cancel out the 3 in the numerator and the 3 in the denominator, leaving me with just 2 times x is greater than 21. From here, we go ahead and divide by 2 on each side. Now that it's 2 times x, we do the opposite, which is division. That's the opposite of multiplication there. When I divide 2 on each side, I get x is greater than 21 divided by 2, which would be 10.5. Find the number. Well, the number must be greater than 10.5. We'll round up to the nearest whole number, having 11 as the number. Again, it cannot be 10.5 because there's no equal to underneath. It's just greater than 10.5, so any number above that would make this inequality true. That's why I rounded up to 11. Linear inequality word problems with two variables. So how can we tell that we're doing a word problem with two variables? We have two unknown categories. There's two specific unknown categories. We'll take a look at what we mean in the first problem here. The cheerleaders at the high school need to earn money to help pay for their uniforms. They plan to have a fundraiser selling two different types of chocolate bars. They need at least 200. That means they're looking to raise 200 or more. Because with $200, they can buy their cheer uniforms. With anything less, they would be unable to purchase them. With anything more, they could buy any extra materials or supplies they need for the year. For every chocolate bar with a peanut butter filling, so right away that is going to be my Y as labeled here, but we have chocolates with peanut butter, and they will make a profit of 80 cents each. So that will be 0.80 with the peanut butter. We'll put PB there for those chocolates in that information. Now, for every chocolate bar with almonds, that's talking about yet another chocolate we're selling, but now with almonds. So that's different than peanut butter. So that's the two unknown categories we were talking about. Those sell at a different price and make a different profit of $8 each almond bar. So because they're different prices in different categories, different variables, we have two of them here. So we can swap out the almonds for X, like it said in the problem, our peanut butter chocolates for Y, and having it greater than or equal to 200. That way we could graph this if ever need be. For example, F, we have an event planner ordering centerpieces and garlands for a holiday party. So again, that right away tells me I'm purchasing centerpieces and garlands. Most likely they're different prices, so I know I have two unknown categories. Well, I was right because the garland's price is $42 each. So 42 each garland. So 42 per garland means 42 times the garland amount. Then we have an and here, which means we're combining that with each centerpiece costing $5. So since each centerpiece costs $5, again, that's multiplication, but it's a centerpiece, not a garland. So we do a different variable, let's say y, after we write this out. And this will be 5 per centerpiece. So if I buy one centerpiece, it's just $5. If I buy two centerpieces, it's 10, etc., etc. The planner has been given a total floral budget of no more than $830. That the budget in the contract agreed on was that they would spend less than or equal to $830. That's what they're paying with the money they have and have budgeted for the holiday party. No more, because money's got to go elsewhere, maybe for food or other applications. So we get 42, let's trade out garland for X, plus 5, let's trade out centerpieces for Y, like we labeled back in the problem, and have that less than or equal to 830. Again, we can spend 830 on the centerpieces and garland, but we have no more than that. That is the maximum we have in our budget, nothing more.